Hello everyone, I am Dr. Berna Devecioğlu from Adolescent Hospital, Department of Child and Adolescent Psychiatry, and in this presentation I will be talking about neurobiological mechanisms and pharmacological approaches. My structure will be as seen. Let's move on with the introduction. First of all, I would like to the definition of the addiction was told and explained by Ms. Zeynep. It's developing a usage habit and continuing it. There are behavioral substance use addictions. And when we say behavioral addictions, those are existent in daily life, and it has a natural avoiding feeling like gambling, digital addictions, and other behaviors that come into surface later on. In the child and adolescent psychiatry, as we are one psychiatrist working in that field, we have a lot of applications in our clinic. Like the first reason is not exactly this, but towards the end of the evaluations, we always talk about screen time, and even though parent or the child specifies it that this regulation and focusing problems has screen time as the main issue underneath. Diagnosing those and understanding the reason and intervening them is really important. But about this, diagnostically arguments are going on. As the concept, that kind of an behavioral addiction, do they really exist? If so, how can we diagnose it? Where to put the line? Where to draw the line? And technically, which content that person is addicted to. There are no only one definition and subclusters. There are some doubts in the definition. Those digital addictions were included in the diagnostic criteria in 2011, but those depend on subjective scale. So this is why arguments were continuing. It does not only about playing games on digital portals and tools. It's like depending on subjective data. This is why NIMH uses RDOC principles. It's like that mental health issues, cognition, and behaviors has different domains that causes effects on neurotransmitters. There are subjective symptoms, though we biological disorders that involve brain circuits that implicate specific domains of cognition, emotion, and behavior. There are some question marks in our hand. Those mental health issues are not actually brain diseases. We can't call it that. So are we putting the individual's real aside? Is that fate? That kind of argument is going on. Even though those arguments are going on, we still try to understand what's going on with those individuals' brains in the neurobiological level. We have to talk about the neurobiology of addictions first, and we'll be talking about the theories, and they are all focusing on those kind of addictions. When we talk about the neurobiology of addiction, it has a three-pillar loop: substance or behavior. In our case, digital usage was extreme. Then we check out a brain. There was a negative effect, a withdrawal effect, so to say. Then it is actually directing the individual, and this is why people has preoccupation and anticipation, like craving. This important loop with three pillars causes neuroplastic changes in the brain, reward stress and executive function systems of the brain. And in these three phases of this addiction, when we check out neuroanatomic areas of the brain, dorsal striatum ventral, theraventral nucleus accumbens, and the motor cortex, those are reward and pleasure loops areas of the brain. And secondarily, we have the secondary loop in the withdrawal and negative effects phase. We have amygdala and abenula working on, and third, about behaviors and preoccupation phase, we have some units. Means the part of organizing how to reaching out to those material or the behavioral. Then PFC and ACC and LOFC is actually included, and insula. In transmitter changes, synaptic neurotransmitter functions, like gross screening changes could be shown here. Behavioral addictions are showing all those results. And well, why I am talking through this on addiction, behavioral addictions, the afflicted thing is not to a specific substance or activity, but to the associated brain response. This is why this three-stage addiction cycle, binge or craving, also applies to non-drug or process addiction. So this is also shown by the studies. And behavioral addictions brings failures in self-regulation, transition from impulsivity to compulsivity, and chronic relapsing pattern. And similar neurobiological features are common point of those related to three stages: neuroanatomic areas, reward deficits, stress axis sensitization and dysregulation, impaired executive control is characterized neurobiologically. I would like to talk about the theories first. As I talked about previously, as a model, we can just imagine it in our minds. Of course, neurobiological data will be given. When I am giving the data, you can understand it better because the studies were made by imagining this paradigm. When conducting this study, it's mostly temporal and topographically. You can check out the parts of the brain and the behaviors of the parts of the brain. It has a reactive system and reflective system, which go network and stop network. There is an imbalance between them, and the behavioral imbalance could cause an addiction, as it is suggested in this model, is in this dual processing model. So the system, the Go network, actually works on momentary awards and in its mesolimbic and mesocortical dopamine pathways, including nucleus accumbens and striatum amygdala. In the stop network, the reflective system regulates inhibitory control and long-term decision making. The parts causes inhibitor control, so prefrontal cortex, insula, hippocampus, because it is linked to memory and learning, and the somatosensory cortex are also related. In this model, says conceptualize it has two powers. If one of them is stronger than other, there might be an impulsivity and loss of control. This is also related to substance use disorders and behavioral addictions and ADHD and neurodevelopmental disorders. The adolescence itself, as we all know, is a time frame that we saw this imbalance, and impulsivity is higher than other times of our lives, especially in adolescence, are particularly vulnerable to ongoing professional maturation. Natural ghost of imbalance explains why addictions often begin in the youth, and this might make us understand better these two theories that I talked about conceptually, touching up on addiction. Now I will be talking about the theories that are touching up on effective part of this addiction. People got pleasure from doing it. Then, even though they don't get that pleasure compulsively, they continue doing that behavior. Why is that? Solomon and Corbett has a study suggesting affective dynamics in the transition to addiction. Of course, that theory structured on the neurobiological basis, it is actually suggesting that motivation and addiction are closely tied to pleasure-related and affective states in order to give an effective response by the brain. It has two processes and two responses to balance this condition. When you are developing tolerance, and then other one is repetitive and getting stronger. Afterwards, these behaviors award feeling is decreased, but the secondary response is increasing, so the negative feeling is increasing. In order to avoid that, it is a behavior that is done compulsively to balance that first phase. In the before conducting that compulsion, it has a tension feeling in the individual. In order to ease it, it is a response behavior in the further stages of that addiction. In the neurobiological basis, it involves adaptations in the brain's reward and stress systems. It is like there are some avoid cycles. It has changes. Dopamine functions are decreasing, and also in other systems, the hypothalamus and supine norepinephrine molecules are increasing, and organism changes the homeostatic status of itself. If we can show a table, its homeostasis is a normal balanced state, and we will be moving on with an analytic state if some changes happening on this part of the brain. Diabetic also has a similar explanation. In drug addiction, we have that kind of allostatic process, as you can see in the be like an hedonic emotional y axis and x axis in the non-dependent drug naive individuals. In the table A, in the 0 point, we have a stimulus causing positive feeling. Then opioids are increasing again in the organism. We have opposite processes theory going on, and it decreases. Then we have balance. When we provide that balance with the CRF and the norepinephrine increase and NPY decrease, when we say the total motivational balance, I would like to take your attention to this part. We have a new hedonic set point after that addiction. It's lower than the other one, and that 0 point get lower. Again, individual has a response to the reward but then it gets dropped really easily, and the imbalance actually has a larger gap than with the has a huge increase in the neurochemicals afterwards. You can see these thin arrows and bold arrows. How can we think it like that in a clinical environment? The negative feeling is so different than we endure it. This collapse, even though this collapse, it shouldn't be excluding the substance towards the outside. It's a new allostatic state. We talked about that theory. It was an affected element, an incentive salience hypothesis we'll be talking about now. It could be translated to Turkish. It's in addiction, stimuli such as notifications require exaggerated motivational value so that desire will increase. Motivational value is huge. It is like wanting it a lot, even though it is not liked that much as used to, and it is related to the dysregulation in the brain. I mean, I have very little time. Can we move on 5 minutes more? The pleasure and desire difference we should talk about neuroanatomically. Pleasure is like little hotspots distributed throughout the brain. But desire and word circuits are much in much complexer circuits that, like you can see it in the darker areas. When you desire, it is related to dopamine, but the pleasure is not related to dopamine. We had a mouse trial. When they get pleasure, they have a good face changes, good mimics, positive mimics, and when the people don't like it, it has negative mimics that it don't have any motivation towards the thing that doesn't give the individual pleasure, and the desire has a lot of desire toward the thing that gave the individual pleasure, and after the individuals get that reward, they don't want like it that much afterwards after developing an addiction. So here we have conditioned reinforcement as an important mechanism. Those digital cues actually directs that long-term decision-making mechanisms. Neurobiological evidences like decreased activity in prefrontal cortex, about cue salience, and activity increased. I will be moving forward a bit quickly. It's like that. Neuroimagining and functional brain abnormalities will be talked about in this part of the presentation. I will not talk about studies. It will extend my time. I will be summarizing the neuroimaging models. What can we use structurally and functionally? We have fMRI, recent study fMRI, VBM, PET, and EEG, and DTI about internet game addiction. The findings on human studies and rats couldn't be actually beneficial for this kind of usage. We found that prefrontal cortex dysfunction in the studies that are made, the PFC, VMPFC, and ACC, and impaired inhibitor control and connectivity issues about the reward system alterations, striatum ventral tegmental area, and reduced dopamine receptor availability and balance reward sensitivity has been observed. We also saw the main emotional regulation region changes. It is about the emotional balance, organization, and the insula, amygdala, parental context, hippocampus, and occipital cortex also shown changes about memory and processing regions, and there are some changes in the sensory integration as well. Are they the reason, or the brain that has that kind of structures are preferring playing games? Could be argued there are no balance established yet. This is the summary of the anatomical picture of those regions. We can saw the volume decrease in the parts of the brain that are very inferior temporal gyrus and insula anterior cingulate and SMA were seen. And this showed activation to the gaming and internet activities when we compare it to the normal individual. Of course, someone playing games, this is important. I mean, if you play a game, you expect these parts are expected to activate those places in the brain. So this is why that's not actually reasonable to show this kind of a chart. Why those addictions matter? I will talk about two studies. First of all, we made it with children in a really early stage of life in a young age. In the In that 47 children, increased screen-based media use, lower microstructural integrity of brain-mind matter was seen, and in the ABCD study, we saw a negative correlation between screen media activity and cortical thickness. And this kind of study, we don't have the reasonability. Clearly, it should have further studies. So the structural changes should be seen. This kind of study is important to see those kind of changes. Maybe, I mean, when we say something scientific to the parents, their adaptation is also increased. In this kind of group, as the child and adolescent psychiatrists, neurodevelopmentally, we are in a sensitive group. When we talk about adolescent brain, prefrontal cortex has a delayed maturation and increased responsibility to digital technologies existed. Weaker self-regulation and planning in youth is existent, and the long-term overstimulation's effect is not known. So all those neurobiological mechanisms has an immature group that has identity development, peer influence, and emotional regulation challenges, and daily life identities, game profile identities, and this is why there is a delayed identity formation. After some period of time, all those adolescent features make those children more possible to more open to that kind of addiction. It is continuing until later stages of life. You can have 30-year-old game addiction individual. Pharmacological approaches, it is like in this kind of digital addictions, we are focusing on psychotherapy and psychoeducational primary treatments. I mean, we are not prescribing any kind of a medicine to fix this gaming addiction, but in the comorbidities, we could think about prescribing a medicine. I'm ending it. What kind of medicine could be used? Antidepressants again, naltrexone, antipsychotics. And according to the comorbidity, we are prescribing these medicines, and in the bupropion is the most used and 60% group of medicine. It's itself actually effective in this kind of comorbidity, and comorbid depression existence in adolescents is effective. I'm sorry I'm extending my time. Thank you very much for listening.